Let's take a look at the simplification of another value, which is the square root of negative 20. Now, in this case, you always want to begin by trying to pull the I out, right? Trying to pull the I out, which means identifying where the square root of negative 1 is, turning that into I. Okay, so I'm first going to split this up as the square root of 20 times negative 1, right? In order to get negative 20, it had to have been the product of 20 times negative 1. All right, what that allows us to do now is say, okay, well, this is actually going to be the square root of 20 times the square root of negative 1. We know what the square root of negative 1 is. We know that that is I, right? So this is going to allow us to substitute the square root of negative 1 with the letter I. And then what I have is the square root of 20 times I, all right? I will always be a product outside of the radical, okay? It does not go inside the radical. It actually stays outside the radical. Okay, so you notice I like to draw a little stem right here to indicate where my square root ends and then delineate what number is inside the square root versus what is outside the square root. All right, now you might be thinking, okay, I'm probably done. Not quite, all right? We still want to simplify the square root of 20, right? The square root of 20 can be simplified. So what we do is we look for ways to simplify 20 by doing a factor tree. Okay, so I can take 20 off to the side and I start splitting it up into a factor tree. Now, because it's a square root, what I'm looking for, there's an invisible 2 outside of it, which means I'm looking for the same number twice, right? Or a pair of numbers. When I factor this down, I'm looking for the same number twice. So if I start breaking this down via factor tree, I know I could do 5 times 4. 5 cannot be broken down any further, right? Because it would just be 1 times 5. So 5 is prime. But 4 can be broken down into 2 times 2. Now, notice what I have. I have a pair of 2s, right? That's what I was looking for. I was looking for a pair of numbers. Anytime you have a pair of numbers, that pair is a value that can be taken out of the square root. Any number that is not a pair, such as the 5, I like to box it because it represents that it's a number that must remain inside the square root, okay? Here's another way to look at it. I could take the square root of 20, and that could also be written as the square root of 4 times the square root of 5 times I. Now, square root of 5, we can't take the square root of 5 because we don't know what that is, right? It's not an integer, but we do know the square root of 4. The square root of 4 ends up being 2. So 2 times root 5 times I. And that would be the simplest way to write this. 2 square root of I. Okay? And there it is.